Computer science is a vast career in today's age, but inside all the categories of computer science lies a more specialized area, game development. Game development is the process of making a game with programming, art, and a lot of trial and error. The general process of making a game is breaking each bit down into its own parts, but it's also important to choose a game engine before you start. A game engine provides you the tools for graphics, physics, programming tools, etc. The engine I will be using for all examples in this video will be the Unity game engine. So let's say I want to make a square move on my screen using my keyboard. To break each component down, I would need to add a square object into my screen, add physics to the object, disable gravity, and then add a new custom script telling it to move based on the direction of my input. This concept is scaled higher and higher as you continue to work on your game and make the objects interact with each other. You could see an example on how complex this gets with a simple virtual reality character controller setup. So now, you may be wondering how one person can learn all of these concepts that seem so advanced, but personally, I've found all the resources I've needed to learn game development on YouTube and the Unity forums, where people help each other with whatever they need. Other ways you could get into the game development career is taking computer science in college or high school, but some courses in college may include game development as majors and minors. Hackathons are also a great way to learn and grow as a developer while also competing against other people for prizes. A hackathon is an event for programmers where you enter a team and create an application, game, or any project to compete in a track like best usage of audio or most immersive game. I personally have done 2 hackathons so far, and my team in Reality Hack at MIT won Best Game Development Prototype this year.
Key mechanic and try to decorate it, which we really like here at the prototyping track, so that was really cool. But now, the team that will receive $1,500 in cash, or the game, is Battlefish by Obscura. So congratulations. 43, if you're here, please show yourselves and say a few words. Thank you.
Hello, another win for the Revolution Hotel. No! Oh,
Another example of game development experience I have is having a game on Steam, the largest PC game market there is. Now, all of this information about game development, except the mention of hackathons, are about solo game development, but game studios build teams of developers with different specialties like 3D modelers, animators, programmers, and more. I personally don't have much experience aside from Reality Hack on working with a team, but luckily I happen to know someone who does work on a team professionally in the VR industry, which is why I decided to interview Jack English. Jack English is a developer at the game studio called AEXLAB, which specializes in their own online multiplayer VR game called Veil. And I asked him about working with a team and some other topics including the VR market and how he learned to develop games. Jack says that working with a team is great because you don't have to be a master at everything. You can master your one specific skill and you get to benefit from having other people who are much better at art, etc. than you could ever be. It's very inspiring to see what other coworkers have come up with, and I believe the sum is greater than the whole of its parts. In the past, I've had to create photogrammetry workflows for assets because I wasn't great at the creative or 3D art aspects of game development. This shows how a team of game developers can make a product with much higher quality when each person on a team is good at one specific thing. Now, one thing many VR developers consider at the moment is the target platform to develop for. In the older days of VR, headsets would only be able to work with a computer and trackers that connect to it. So you would need a good computer to play VR, but in return, the games made for VR would run well and look good. With new headsets like Meta's Quest platform, which needs no PC and no external trackers to work, the barrier of entry to play VR has lowered by far. But these standalone headsets, as the industry calls it, cannot run games nearly as well due to their weaker hardware, identical to a new Android phone. So I decided to ask Jack, how do you think standalone headsets like the Meta Quest series affect the quality of games being developed compared to if a game was built for better hardware like PC VR? And he said, that's a very diverse question. On the surface, one would probably think that much smaller performance budget of a Quest standalone compared to PC is very limiting for graphics, world scale, and immersion. And that's definitely true to an extent. But overall, I think that the affordability and mass marketable simplicity of Quest has made VR games much more viable to be made. At the end of the day, games financially only work at scale where you have a TAM, total addressable market, of tens or hundreds of millions of players to sell to. PC VR is simply nowhere near that, but Quest has allowed a market that is financially viable for some studios without throwing money into a fire, which Meta is still definitely guilty of. VR games are able to be larger scope and scale with expectation of return on investment. It's complicated, and a lot of gamers are definitely unhappy about the direction that Quest has pushed the VR gaming market, but I think it would be much, much smaller without it. So yes, while these standalone headsets do limit some potential for immersion and visual fidelity, they expand the market for VR games as a whole. So then, how is he able to learn everything that he needed to know for game development? When I asked him this, he said, I've personally found benefit in manually following super discounted Udemy courses, but you also have to apply what you learned in your own project afterwards to really learn it. Tutorials can be helpful for specific things that you're stuck on, but they likely won't have the best solution for your specific situation. Ultimately, it will take years of making mistakes and remaking things and learning lots of little things to start making good decisions, but it's all a part of the learning process. Also, if you're interested in specifically programming, a CS degree will help a lot with good fundamental programming understanding. So that's a bit about the career of game development. A fun career in my opinion, but not without its hard work required and constant upwards learning curve to create more advanced projects.